Good morning, everybody. Thank you so much for joining us today for our May webinar on how to seal difficult powders and slurries. We're happy you're all here with us today, and we're also very happy to have Zach Nepa with us, and it's his birthday today, so happy birthday, Zach. We're making him do a webinar on his birthday. So before we launch into the webinar, we're going to give everyone a few minutes to join because we historically have some folks join us a little late. So Zach, I wanted to ask you a question. What is the craziest or most interesting application you have dealt with in your career?
I would have to go with a chocolate factory in Chicago where when you walked through it, there was more chocolate on the floor than there was in the mixers, and they were collecting it all in buckets and shipping it off to be fed to pigs on farms. And we solved that problem by sealing all that chocolate up with an air seal.
Wow, that is
across
a
a
lot of
number of
chocolate.
applications. I'm sorry.
You finished what you were saying.
Oh, I was just saying it was across a number of applications that we did this on. We did it probably on 20 to 30 different conches that were just leaking everywhere, and now they no longer leak. And unfortunately for the pig farms, they have to go for another source of chocolate, but we did solve the problem, and now we're getting the chocolate out, more chocolate for human consumption rather than pig consumption.
That's amazing. That's a lot of chocolate to be on the floor.
It is. It is. And it was nonstop. It was just an avalanche of chocolate, but now it's all contained.
And I think we're going to talk about a similar application later in this webinar. So
Most
it's
likely.
good that that's your craziest application. So one other thing we want to know before we get started, everyone online, what made you decide to join us today for this webinar? Why are you here? We have a chat section on the right-hand side of GoToWebinar, and you can just chat in there. What made you decide to join this webinar? We'd love to hear more from you about why these are content pieces that you enjoy and like to come in. So if you want to, let us know in the chat. And again, we have started this webinar series called Seal Connect Classroom. We have monthly webinars from SEPCO experts and from other reliability experts in the industry every month that educate in a non-branded way on sealing and reliability and maintenance and any topics around those. You can join the chat on social media using hashtag SealConnect. You can also ask questions during the webinar in the question section on the right-hand side. You can type in questions anytime, and we will either answer them at the end of Zach's presentation, or we will potentially ask them during the presentation if it's something that's really relevant and timely. You will have the slides emailed to you. The webinar is being recorded, and we will send those to you about 24 hours after the webinar ends. And there are also 2 handouts. Under the handout section on the right-hand side, there is a white paper on seal technology, and there is a product brochure about the technology that will be discussed today. So I think that's everything. Again, if you have questions, please make sure that you ask them in the question section. And I am going to hand it over to you, Zach. And if we get any questions in that are timely, we will hop in and ask you. And thanks again for being here with us today.
Thank you for having me. My name is Zach Nepa. I'm a regional manager for SEPCO. I've been doing this actually 7 years now. Started in 2014 in the seal industry. That's after I graduated from Binghamton University in New York. If there's any New Yorkers in here, hello. Hello to everyone else too. So anyway, I'm here today to just kind of go over with everybody the air seal technology that might not be as well known as some other technologies, as it's relatively new. Today we're going to talk about why powders and slurries are so difficult to seal, which they are. There's a number of reasons for that. where the weak spots are in the applications and what we can do to solve that. We'll also go over some successes that we've had in the past on a variety of different applications, offering a solution of technology for those applications, and then we'll go into an explanation of how the technology, the air seal technology, actually works and how it's effective. Now here's a poll. These are a number of technologies that are most likely used in these applications. I would say over 90% are using one of these technologies. Feel free to answer this poll and we can discuss the answers later.
Let me launch this for us so that everyone can answer.
I'll give everyone a minute to go through that.
Yep. And you can check more than one. So check all that apply. And we are only at 33%, so we'll give you a little bit more time to vote. A few more seconds. All right, so we're going to close the poll now. And let's look at the results. So interestingly enough, and not surprising, 100% of you are using packing, 60% mechanical seals, 60% lip seals, and 40% air seals, which is very exciting. I was not expecting air seals to be that high. Were you, Zach?
No, I wasn't.
Okay, so thank y'all for answering. Not surprised that everybody uses packing. Okay, we're going to get rid of these results. And Zach, we're ready to move on to the next slide.
Okay, so I'm sure everybody's in here because they deal with powders and slurries in the plants that they work in, and there's a number of issues that they cause. We'll start with powders. Powders are dry, and you cannot use a liquid to seal those like you would on a mechanical seal. So what you end up with is a sealing solution such as packing or a lip seal, which running dry combined with the friction of powders creates leak paths, creates grooves in the shaft. Typically is where you see these leak paths being formed by the friction of the powder getting underneath the packing. And slurries as well, although they're wet, there's times where you can't add water to those. And also there tend to be in applications that have longer shafts and bigger shafts as far as the diameter is concerned that create run out issues, that create bearing leaks. And when those shafts start to move and have run out, those bigger shafts, they do damage to the seals. So the shaft deflection is a major issue that goes on with all types of mixer applications. And over time it wears down, creates clearances, and sooner or later the product is leaking on the floor. There's many weak spots in these applications. The question is, are you using the right technology? As the aforementioned factors that affect the rotating equipment we discussed, changing your seal technology can definitely help this issue. Updating technology is very critical, and you have to stay with the times. And as long as there's leaks, new technologies will be pursued, and that's where we are with the air seal. Here's some examples that you would likely see, and I don't have a rundown of who's in this webinar, but hopefully we can get the idea from this variety of different applications. You have bread mixers, which could be either dough or flour ingredients, any type of additives. Chocolate, of course, everybody loves chocolate that can eat it. Cement is a very, very common industry where dry powders cause a number of issues with bearings and shafts, and as far as leakage goes as well. And then seasonings. I don't know how many of you have been in a seasonings plant, but when that stuff leaks, you can barely breathe. It's very, very strong, and it'll linger with you after you leave for a while. So we want to contain that as much as possible. And of course, anything dry could cause a fire hazard. Anything wet could cause slipping hazards. So overall, it's a better rule of thumb to not have product on the floor, not only for cost issue, of losing product, but for maintenance, reliability, and safety as well. Bread mixers are one that's it's very, very common. As we know, America loves bread. Um, a lot of things can go wrong with a bread mixer. Start with the ingredients actually getting into the packing, which is, as everybody here is using packing. What happens is packing tends to be very soft, especially food grade packings, because you have to use a PTFE, and that PTFE will allow for any type of product that gets through it. It will embed itself in the packing itself and form a sort of a sandpaper, if you will, that'll wear on the shaft. So that causes wear. And then once that wear starts, there is a chain reaction, because now the product has a more open path to leak onto the floor to. And then once that happens, you'd have to, cleanup becomes an issue, maintenance becomes an issue. Then naturally you'd have slips and falls that can occur from that as well. Product loss it doesn't seem that expensive. It just seems like flour, but as that accumulates over time, you're talking buckets and buckets of product leaking per day. That gets really, really expensive over time. And then another major factor would be bearing failure. As product gets into the bearings, it gets into the oil, and then it creates a bearing failure, which could actually cause run out, which would create a cycle of new issues that come with it. So you want to eliminate the possibility of any product leaking out from the start. Bread mixers, what we use is, or what we recommend, is a non-contact air seal that completely seals any product, or completely prevents any product from being able to leak out. And it's very, very simple. It just mounts in the place where you would use either your packing follower or mount a mechanical seal just right outside the stuffing box. And very simply put, you run air to this seal, and it creates a pressure barrier that doesn't allow any product to leak. So it's also a non-contact seal, so it's designed to last the life of the equipment. And furthermore, it has an internal clearance, which we will show here in a few minutes, a few slides from now, that allows for the shaft to run without causing damage to the seal, which is what really sets it apart, because it's a non-contact with a movement capability, excuse me. So ready for the next slide.
Yeah, I'm actually, since we're at the end of the bread mixer, someone asked in our chat section, or let us know that they have joined to understand powder sealing in a screw mixer. We don't specifically talk about that in
Okay, as in the
this.
screw conveyor, I would assume?
Well, we do talk about that in the potato chip seasoning. So just know that there is someone on that is interested in the screw conveyor and a screw mixer. So
Okay.
I just wanted to point that out before we move forward.
And I'll
And I'll
back
go to
up,
the next.
whether it's a bread mixer, a screw conveyor, a conch for chocolate, a blender, a hopper, a pulper, and the paper mills. Fundamentally, they all work the same, because the shaft is it's just a rotating shaft supported by a bearing, and there's a vessel that it's moving the product through. And so what we do, regardless of what application it is, provided that there's room for it, we will be able to mount an air seal in between the housing and the shaft and the bearing. So there's
Okay,
a
great.
number of applications out there that are applicable. We could probably get that number into the 30s if we really focused on it, but fundamentally they all behave the same way.
Okay, great. I am going to mute my mic and go to the next slide now, but since that popped in, I wanted to make sure you knew about that.
Okay. Chocolate conches, you can see how this started out. This right here is actually it's almost not even packing or a seal. It's kind of a combination of metals and plastics that are used to create a dam. And you can see this is what I was talking about in that chocolate plant earlier, about how that chocolate just leaks everywhere. And you can imagine that just a steady flow. It's almost like a chocolate fountain at a buffet, the flow rate of it. And that's what we use the air seal to fix. And as you can see, I kind of already went over these issues, but the housekeeping issues are really tedious, constantly replacing, packing the seals, and then of course the shaft wear and liability issues that come with that as well. And here's the after photo. So this is what they look like before. Okay, this was actually a different picture than the last one, but we replaced this piece here with an air seal. And you can see where there's no chocolate leaking out of the air seal. This is after it had been running. There's no chocolate leaking out of the air seal, whereas before it was just a steady stream. And this plant actually saved over 2 millions that we've documented. It could be more in product loss as well. And then their housekeeping issues are now addressed. They don't have to have maintenance schedules to replace the packing or seals at any point. And the shaft wear is also eliminated. Cement's another one. Obviously, we all walk on cement every day, pretty much in the modern world. So there's a number of plants out there that are moving cement. And cement, you can imagine, in its driest form, it's not only abrasive and hard to manage, but it's hard to breathe around when it gets flying up in the air. So eventually, what'll happen is that the cement leaks out, gets into the oil of the bearing, and you can see that that in the very bottom of that image is actually a pillow block bearing that's just submerged in cement. And what happens is that cement gets into that oil, creates wear in the bearing, which leads you back to your issues with run out, because as the bearing begins to wear, it creates run out, which creates that cycle of wearing the shaft and more leakage. So it's really once you start leaking, it becomes sort of an endless cycle where you're chasing your tail and you don't necessarily know where you are in the cycle because it's leaking. So it's best to nip this in the bud and take care of it earlier on with an air seal technology. Here is the after photo. As you can see, it's much cleaner. The air seal is sandwiched in between the bearing and the housing. Now, normally where that product was leaking out was at the housing where you see the air seal, and then it was getting into that bearing right there. And so just by using air seal technology, that problem is now solved. There's no downtime. There's the mixer lasts much longer because the bearing lasts much longer, and housekeeping issues are eliminated. So what this also, that's really important to actually note on these housekeeping and safety issues and maintenance issues, is there's tremendous cost savings just in labor and just saving your time, and there's more opportunities created to solve other problems so you're not chasing the same problem over and over again. And eventually you'd like to be almost not a maintenance free mill, because that's not feasible, but limit all the maintenance that you can. And this helps you do that. Seasonings. Now, I had mentioned earlier with seasonings is when they leak, there's an additional problem with seasonings beyond all the issues that we discussed earlier, and that is the seasoning itself. If you try to breathe that in, it's really a nightmare. You get that all over the place. The more that leaks, the more profound the environment becomes, because it's really hard to breathe. So containing seasonings is really important. Now, you're never going to get all of it, because it comes in bags and gets poured into the top of the vessel, but at the same time, it's really important to keep it contained in the vessel once it is in there, so that it's not flying around everywhere, and it creates a number of issues. It's also tends to be more flammable than others. So as it gets into, it just gets everywhere, there's more of a fire risk, if you will. But Same thing as all the other powders. It just wants to leak its way out, especially when it's not contained by anything other than a packing, and it can't be contained by a mechanical seal because mechanical seal would require a fluid barrier. So fluid mixing with your seasonings isn't good unless you're already in your soup. All right, and then this is a nice after photo. I should note that the seasoning that you see on below it is from above because this was a stacked mixer or a stacked conveyor, and there was the air seal was just tried on the one below. But once it's installed, there would be no leakage out of the shaft at all. Um, where the arrow is pointing is where product would normally leak under other circumstances using a different sealing technology. It would just leak through the shaft as such. And what the air seal does is prevents that from happening. So in this particular case, everything has improved, whether it was downtime's improved. There's actually been no downtime on this application since it's been put in. The housekeeping is kept to a near minimum, and the only housekeeping necessary is from spices leaking from above and not out the seal itself, and which we would have no control over. And so it's just a pretty profound difference that it makes. Now we'll talk about the actual technology itself and how it works. It's one of the simpler technologies in the world, which also makes it more robust because anything that gets too complex, they say the more complex it is, the more that can go wrong. We have a very simple design, and we will go into that here. Very simply put, you mount this seal where you would mount either a packing follower or a mechanical seal. And then instead of running water to it, you run air to it. And then the air is fed internally to a floating air throttle, which is represented by that green piece in the center. That I get a lot of questions about what material that is. It's high grade thermoplastic, and it's whatever material is required for the application based on the product itself. So essentially what happens is air runs in here and it creates a pressure barrier, and it's fed into that throttle, and then it's distributed across the shaft after it builds a back pressure inside. And that pressure barrier, as long as there's more pressure on the seal than there is head pressure on the application, which is very easy to accomplish on most powder applications, as there's almost little to no pressure at all on the product side, is the air will form a pressure barrier and not allow the product to cross. Now, if you look at the throttle internally, the floating throttle, we call it a floating throttle because it quite literally floats with the shaft. So as there's shaft movement, there's the throttle will take a little bump from the shaft, but a non-frictional contact, and it'll realign itself around the shaft as the shaft moves. So if you have an application where there already is a lot of run out, and some applications like screw conveyors have an inherent level of run out regardless of whether you have a brand new bearing or your bearing's 10 years old. Just longer shafts tend to have more run out. So that throttle accommodates any sort of shaft run out or shaft deflection that would come with it. Furthermore, axially, the shaft is allowed to migrate through without creating any contact as well. So essentially, it's just an air barrier that's created and harnessed by this seal, and from there it accommodates the movement as well. There's the way it distributes is there's a number of holes in the throttle, very small holes that not only receive the air, but once they receive the air, they distribute it through the center of the shaft. And you will get air will bleed to both sides of the product. More would bleed out the environment, but it's a very, very limited amount of air because remember, the back pressure is already built and it's tight clearances. So I would liken it to holding your hand up to your air conditioning on low in your car in terms of air consumption. It's very, very limited air consumption, which is one of the number one questions that we always get is because air is expensive, but this air is, we're typically seeing around 1 CFM per shaft inch on the high side of air consumption. So it's a very, very limited amount of air. And the back pressure and tight clearances allow it to restrict flow while still maintaining a seal. Here's an actual analysis of how the air is distributed. Now, these lines that you see are actually representative of the holes on the outside and the channels that they run through, that the air runs through on the inside. So the air is very, very harnessed and very controlled running through the throttle. There's a number of industries that we work in with this product, and it's frankly it can be applied to any application where air is allowed in the process and it's moving product through any rotating application. Excuse me. Pulp and paper is one of the biggest industries that we're in. Agitators, which are used to mix up paper stock, hydropulpers, stock chests, and a number of other applications in the paper industry are sealed with using air seal technology. Pulp and paper is one of the most challenging to use packing in mechanical seals because it's very common that the equipment is very old, and even if it's not old, it's larger shafts that tend to have a lot of movement, and the product itself is sometimes distributed into the vessel at uneven amounts. As you can see, there's pictures of bales right there of recycled paper, and when that gets dumped into a vessel, say for example a pulper, what happens is it jars the shaft and it creates sort of a shaft deflection, and the air seal accommodates that as well. Food and beverage industry, that's everywhere. Obviously we all eat food and drink beverages. The number of applications is almost unlimited, and the form is almost unlimited. I mean, you have anywhere from seasonings to cracker dough to sugar to juices to frozen vegetables. There's a number of different types of foods that get moved around in a number of different types of applications, anywhere from rotary airlocks to mixers to screw conveyors to hoppers to blenders. It's just anything where a shaft is going through a vessel that product is in and is supported by a bearing is typically a potential application for an air seal. Also, food and pharmaceutical, anything with powders in general is another place to look. As you can see in this one photo, that's a calcium carbonate plant. This is a before picture. I don't know that we actually have the after picture in this presentation, but that powder just it piles up in mounds and mounds and mounds, and then it becomes a process again where you have to reclaim that. You have to run it back through a cleaning process, and it's not simple, especially with the FDA snooping around these mills and plants. Another very common question we get asked is, are they split or solid? And the answer is both. It depends on what you need. Typically, I recommend split, but we'll start with solid here. A solid design I would use on applications where they're easily accessible and you wouldn't have to decouple the motor and the application to install it. So say for an example, like a screw conveyor on the non-drive side, it's very easy to install a solid air seal because all you have to do is slide the bearing back and then slide the air seal on. What we typically recommend in most applications though is split because the time saving that goes along with split. And Lori, can you go to, yeah, thank you. The split seal here, as you can see, when it comes together, it performs exactly as a solid because we have it secured tightly enough and the machining is to perfection on that. And essentially what this does is a split seal saves you significant amount of time in terms of setting up the application itself or installing the seal itself, because you wouldn't have to decouple the application from its motor or its gearbox, or frankly its bearing as well. So you can go to the next. Now installation is very simple. At first it seems a little tricky, but it's quite simple. This auxiliary air supply that you see here on the right is optional, but we do recommend it just so that you can manage your air consumption. And if you need a filter and pressure regulator, that's there. It really depends on the application and the plant that you're in, whether you would need that or not. But the most important part is to know that you need to run air to the outside of the air seal, and then on the other side have a pressure gauge to read to make sure that the air is being fed properly to the seal itself. So quite a simple process there. In terms of actually installing the seal, you'll want to beforehand, make sure that your application, your machine surfaces are smooth, so you don't have any burrs that would cause any issues. Have all the necessary tools on hand. Most plants do have all the necessary tools on hand. I very rarely need more than some wrenches, whether it's Allen's, socket head, or ratchets. And you don't want to over tighten anything because you don't want to strip threads. But this is not hard to not do. Just you can tell when you're getting to the point where you would start stripping. You want to keep air. Let's see here. Keep the air internal sealant and grease free to avoid airflow restrictions. So a lot of times people will put on seals and tend to over lubricate. And what this is not necessary in this application to really, frankly, lubricate it at all. So avoid doing that. And then you also will have to install it symmetrically to the shaft, which is also very simple. That comes with centering clips that allow you to do so. And then you want to make sure the air supply is correct. This is very simple. Just you run the air, you read the pressure gauge. You want to make sure that your pressure gauge is reading above the head pressure you're facing at the application. I usually set it at 5 psi above just to create a buffer to be safe. But frankly, it's a very simple process. You just run the air and check the pressure and make sure that that's good. And you also want to make sure that the air that you're running is suitable for the product. So a lot of times, often people use just plant air, but if it's a product that's very sensitive to plant air, you might use nitrogen nitrogen would be the more common one that you would do, or instrument air. And now we're open for questions.
Hey, Zach, thanks so much for that presentation. It was really good. We have a couple questions already. Please ask your questions now. We have got plenty of time to answer questions, so we're here with you as long as you want us to be, or until noon Central Time. And remember to ask questions, and also the handouts on the right-hand side, if you'd like to download those, you'll need to do that before the webinar ends. And the first question, and Vinod, I hope I'm saying your name right. I'm going to ask the question, but could you also let us know what your product or application is in this? I appreciate the info. He wants to know, can these seals be used for, and you said PVC, so that's the application, I'm sorry. Can these seals be used for PVC twin screw extruders with temperatures on the shaft at 55 to 60 degrees Celsius?
Yes, most likely. Now, is the shaft PVC, or is PVC the product you're sealing?
I assumed the product is PVC, but Vinod, if you can let us know that, that would be great, and you can just put that in the question box.
Either way, it would be doable. The air seal is almost insensitive to what it's facing, as long as there's room for it and the air is allowed in the process, then it would be fine. As far as temperatures go, those temperatures are well within the standard material range, but materials can be adjusted accordingly for whatever temperature or product that you are facing. So it's really, the technology applies across the board. From there, it's just a matter of material selection.
Okay. And if Vinod pops in with the product is PVC and powders are mixed between the screws.
Okay. Yeah, that, I mean, that would be absolutely fine. Yep.
Okay, perfect. All right. Thank you so much, Vinod. One more question we have, and again, we've got time for more if you want to put them in. So you
And you can
mentioned
all
mixed.
send these to my email if you see my email on the screen. I'm assuming I see it.
Yes, it's there.
So I can reply to them if they're more if you have the specific application information, you can send that to my email and I can look into those further. So oftentimes with questions, it does take a few questions on my part to about the application itself to be able to fully answer them. But so if I don't address it entirely here, feel free to email me.
Great point. And also, if you get all the information in an email and it seems pertinent to other people who are registrants. I'm not thinking of
Attendance,
words correctly.
attendees.
um, yes, attendees. We can also write a blog and make sure we email it to anyone who attended, so that if there are further questions, we can let people know.
Okay.
Okay, another question is, so you've mentioned hydropulpers, mixers, agitators, chocolate conches. Is there an air seal for pump applications?
Yes, there is. Um,
And what is involved in that? And is it different from, or, you
there
need,
is slightly different from your standard air seal. The air seal itself would be the same. One example that we have done quite a few air seals on is a Gold's 3175 paper stock pump, but it's also it handles a number of slurries. Um, what we do is we don't want to introduce too much air to the eye of the impeller, so we create sort of a double seal, and it internally in the throat of the stuffing box where packing would normally go, we use bushings and a lantern ring and to create a flush barrier. And then what we do with the air seal is seal the actual flush barrier from leaking out into the process or into the environment, excuse me.
okay, awesome. And are there any specialized applications that you would suggest you try to only use an air seal for, that is something that's super problematic, or um, anything like that?
Frankly, it's more related to the process than it is the application itself. So I wouldn't use anything but an air seal and powder unless there was just no option for it, no room for it. So in powder applications, I wouldn't consider anything else. Um, and that's just because you're going to get wear because there's no liquid use that you can use to seal like you would be able to on a mechanical seal, for example, where you'd be able to use a liquid barrier. And packing works great when you have water running to it, but when the drier applications, it's really tough because you do get that frictional contact. So
And with a
frankly, that
powder, you can't have water.
powder you can't have water. So anywhere you cannot have water, I would almost say that anything else is a non-starter because you are going to have frictional contact anywhere where you can't have a barrier fluid or water. But there's a
Okay.
number of applications. I mean, pulpers and paper mills, for example, is one where anywhere there's any excessive shaft movement is going to create damage to any seal. So pulpers would be one. Anything that has large shafts and significant run out. Ribbon blenders is another application in the food industry that I see quite a bit. But generally speaking, the longer, this isn't always a rule because you can have supportive bearings along the way in the shaft, but the longer the shaft, the longer the shaft is from the bearing, the more likely there is to be run out at that location.
Okay. Well, we have not gotten any more questions. We are finish early. Want to remind everyone we did record this. We will send you the recording and a PDF of the slides. We have a link in the chat to the June webinar, which should be hilarious, from Joe Anderson with Reliability X. He tongue-in-cheek tells us how to do things, but not really how to do things with reliability. And he is also the writer of the Captain Unreliability columns for Plant Services. So we're excited about having him join us next month. And Zach, thank you so much on your birthday for joining us and presenting. And we hope you all enjoyed it. And if you have any questions for Zach, his email is zagin@sepco.com. Send them to him. And thanks again for joining us, and we will see you next month.